I want to go do it.
The only reason why we are doing it again is probably the teacher thinks that we don't know enough.
Good one, Sharon. Alright, so as radiographers, we're responsible for the radiation dose that our patients receive. True or false?
True.
True. And how do we control the radiation dose?
KDP and mass.
KDP and mass. We control KDP and mass, right? Okay, so when we talk about peak KDP, what exactly does that mean?
Highest energy levels.
The highest energy level within, because KDP, for example, if we set 80 KDP, is everything gonna be 80? It's gonna differ, right? So 80 basically represents the highest that it's going to give us. So peak kilovoltage is basically the highest energy level of photons in the X-ray beam. And it's equal to also the highest voltage that is established in the X-ray tube. And we know that KVP controls what? Quality or penetrating power of the X-ray beams.
Yes.
Okay? Mass. We know that mass is MA times seconds. So product of electron tube current and the amount of time in seconds. And it also determines how much radiation is directed towards the patient. Yes.
Here then MA is electron tube current.
MA is the current, and then S is seconds, so the amount of time that the X-ray tube is activated to give us the exposure. Okay? Oh, by the way, I had to show you something. If you guys have your PowerPoint on your laptop, do you know that you can record me talking?
Yeah, something like that, but I don't know how
Hold
to
on,
do
I'll show
it.
you in a second. So that way you don't have to frantically write down everything that I'm saying.
You better use voice recording with your phone.
Not even on your phone, you can actually use voice recorder on your laptop
Oh,
too.
right here where it
Yeah,
says
no, no.
record?
So if you go to recording. Okay, thank you. So go to recording, go to audio. Are you guys doing it with me?
Yo, mine is mine.
And then record sound. Okay, thanks.
That was record
You
sound.
might need to
Oh, okay.
add permissions.
It should let you on your laptops, but this one's asking me for permission.
Yeah, mine's right.
Record audio?
Record audio, and then you can also change the name to like slide number, whatever we're on, so that way you can go back and listen. I'll show you after class if you need help with it, but I just thought that was cool because I did that for Mr. Funk.
Him yelling.
Huh?
Recording him yelling.
No, for MRI.
Yeah, he said he was yelling.
An MRI?
To keep you awake.
He lost his voice.
He said, my voice is a little loud.
It wasn't really yelling.
She's just lying to us left and right. My goodness.
I don't know what my laptop is.
But if your PowerPoint doesn't let you do it, you can also have a voice recorder option on your laptop. They can have it in the background, recording while I'm speaking. Okay, y'all don't seem that impressed.
Thank you, Miss Bonilla.
They don't
They
have
can
it.
use it right.
Are you talking about voice memo?
Voice memo, voice recorder.
I don't know what mine is doing,
We
but
still
my
need the
face is
YouTube
showing on
though, so
mine.
please finish that.
You got your phone camera on?
But it's recording.
Ready, Miss Penny?
Yes, I'm ready.
3,
3, 2, 1.
go.
Alright, so we're good with KVP and mass, correct? Shouldn't be anything complicated. So once again, what does KVP control, Angelica?
The quality.
Our penetrating power, and what does mass control?
Quantity.
Correct. How much radiation is directed towards the patient? Alright, so when x-rays enter a material such as tissue in our patients, we have 3 things that happen, which is absorption, scatter, transmission. Okay. Absorption, we know that when x-rays interact with the atoms and it's absorbed, that's absorption. Number 2, if X-rays interact with the atoms in the patient and it's scattered, it goes off in a different direction, that's scatter. Some may be also a cause for indirect transmission. So they scatter but still transmit through the patient. And then number 3, just transmission, it passes straight through to our IR without interaction. Okay, we good so far?
Yep.
All right, absorbed dose. We've heard this term many, many times. It is the amount of energy that's what?
Not by the tissue.
Deposited within the tissue, okay? So the more electromagnetic energy that's received by our patient, the greater the possibility of biologic damage. All right, so what is primary radiation?
Total radiation from the tube that gets to the patient.
Okay. Any other explanation?
Between the tube and the patient.
Basically, the primary radiation is what exits
The window.
the tube after it has gone through what?
Filtration.
Filtration. And we have 2 kinds of filtration, which are
Inherent
Added
and added.
inherent and added. Where do we find inherent?
Inside the
Inherent.
tube.
Inside the tube.
Built in.
Glass window, that is our inherent filtration. It does not permit low energy photons to pass. And then we have added filtration, which is what?
Which you
It's
add to.
after the window.
I know. What is it made of?
Aluminum.
Aluminum. And then what does the aluminum actually do to our X-ray beam? Hardens it. So it actually raises the effective energy by removing even more low energy components. So the combination of our glass window and aluminum is called permanent inherent filtration. Okay?
No, I'm not.
Yes.
Not this. The glass window is on the is in the tube. It's not the tube.
Glass window.
Now where's this? What?
Where is what?
Where's this glass window?
No, I'm not going over that. That is X-ray 101.
No, so but when you're saying, what are you talking about? What is this?
Where
now?
is the glass window of a tube?
Oh,
It's where the X-rays exit, right under the anode.
so this
The
whole
window.
thing is under the anode.
The window that it exits.
Do you see where those purple
Is the
lines are
glass
coming
The
from?
glass window is the window through which X-rays.
Exit is it? But then this whole thing is the glass window, man.
That's the glass envelope. The window is the.
I mean the cathode, electron, anode. These are everything is the tube, right, man?
Yes.
And the glass window is not the covering that we're seeing over there. That is the covering is the housing, right?
Correct.
So the window is only the window that's in the front.
The window is the area through which the X-rays are exiting.
Just only that much, man. Not
Yeah.
not this whole thing that we're seeing. That is the housing of the tube, right, man?
Yes. So when we talk about glass window, it's I guess a small little window through which X-rays are
This is
exiting.
around. Thanks, man.
So if I ask you a question, the combination of inherent and added filtration is known as what? Permanent inherent filtration. And then the filtered X-ray photon beam is collectively referred to as our primary radiation. Alright. So in diagnostic radiology, we express energy in kilovolts. So when we say kilovolts, we're talking about the energy inside the X-ray tube. But when we're talking about the energy of the electrons, it's slightly different. It's no longer kilovolts, but it's what? Kilo electron volts, because we're talking about electrons now. Okay? And earlier we said that the voltage that we apply, it fluctuates, correct? It's not going to be constant. And then our KDP is going to represent the highest energy that we get. So this sentence, don't let it confuse you. The most energetic photons in the beam cannot have more energy than the electrons that bombard the target. So what that means is the most energetic photons in our X-ray beam. Give me a KVP, Shamika.
120.
120. So the most energetic photon in our beam is going to have what? What
100.
kilovoltage?
KV?
What number?
120.
120. And then our most energetic electrons will have also 120 electron volts. So that basically means when we set 120 kVp, our most energetic X-ray will be 120, and our most energetic electron will also be 120. It's just a difference in how we express it. Instead of kVp, it's going to be keV. All right. Anyone lost?
Isn't it the other way around?
What do you mean?
Because photons is first. And
This basically just means once you set your KVP, your electrons cannot have more energy than your number. That's all that it means. So if your KVP is 80, that means you're going to have the strongest part of your X-ray beam is going to have 80 kVp, correct?
KV.
That also means your electrons cannot have more energy than 80. That's the highest that it can be. That's all it means.
Oh.
So, the voltage of the tube is measured in kV, kilovolts. The photon energy is measured in keV, kilo electron volts. So when we say kV, it can be talking about the voltage of the tube. And then when we're talking about energy of photons, it's going to be electron volts. Okay? What about this question? What determines the highest energy of a photon?
Just set
Which
KV,
we
yeah.
said, yep. But if you want to find the average energy of the photon, we know the highest energy will be what we set. How about if you want to find the average energy?
Divide by
It's a third of it. So for example, if I set 100 kVp, my highest energy will be
33.3.
100. But the average energy will be 33. So basically 100 divided by 3.
Why does it change from KP? Wait.
Because we're talking about energy of photon.
I see it.
So the KVP is the
Voltage across the tube.
so that's the energy we're talking about. Which one is the kilovolts? That's the photon energy. I don't know.
so the KV or KVP is what we control. That right before we shoot the X-ray, that's the voltage in the tube. That's gonna accelerate the electrons to the anode, and then when that photon is created, it's measured in keV.
So when
So
we
the
talk
photon
about
energy is KV.
yes, so when we talk about electrons or photon energy, is going to be in KE.
Kilo electron. When we talk about the
So when it's just regular energy, that's KVV, right? No?
KVP is the voltage that we apply
Okay.
to the
gotcha.
X-ray tube.
Gotcha.
Okay, so if I gave you a question, technologist sets a KVP of 70. What is the average energy of the X-ray photons?
1/3 of 7.
So 70 divided by 3, which would be what? I'm not gonna math.
3 2s are 6, 3 3s are 9, 20.
Yeah,
23
sure, 20
something.
But you get the idea that you divide it by 3, right?
It was 20 from KE.
KEV, yes. So the rule is 1/3 of the KVP that's applied is the average energy. All right, so let's see if you remember from physics. What does potential difference mean?
current.
Okay, voltage, what about the voltage? Why do we need a potential difference for X-ray
For the
production?
flow of current,
So I can go. The
flow of
flow.
electrons.
For the
that's
flow
it.
of electrons, we need to have
A kick.
a difference, right? For electrons to travel through to our anode, there has to be a difference of voltage. So when we set a technique factor of 100 kVp, that's 100,000 volts of potential difference that exists between our cathode and our anode. Does that make sense?
Why do you multiply 1,000 now?
Cause K stands for kilo, so 100 times 1,000 is 100,000. So when we're selecting 100 kVp as a tech, what we're actually
Oh, you're just
doing is
converting.
creating a potential difference of 100,000 volts between the cathode and anode. Alright, what does attenuation mean?
Absorption.
That is not absorbed.
Anything that is not transmitted. So absorption can be absorbed in the patient, and it also can talk about X-rays reducing in intensity and being scattered in another direction, right? So absorption, X-rays interact with the atoms of a patient, and they cease to exist. They're just absorbed. Scatter, X-rays interact with the atoms of the patient. They lose some of their energy, and they will continue to keep going, but at a different angle, a different direction. Direct transmission, what do you think of that is?
Going through
It
the
doesn't
patient.
interfere with anything.
Just go straight through without interaction in the patient? And what is the difference between direct and indirect transmission?
Indirect will get absorbed or absorbed, not scattered.
Not
will-
absorbed, scattered. So indirect transmission is that it keeps going, but it has slowed down and changed direction. Direct is just goes through without interaction. Indirect, it interacts with matter, kind of slows down and changes direction, but still reaches the IR. Okay? So which one of these is useful to us?
Well,
Direct
technically,
is useful. Indirect, it kind of causes a little bit of noise, because we know scatter is, yeah. Which one of them reduces the quality of the diagnostic images? Indirect.
Oh, bless you. Thank you. That was good.
Yes, we can go to the slide again.
Because it's an interactive way that.
This too.
Yeah, so direct, it just goes straight through to the IR.
Yeah, I was talking about how it talks about as a result of scatter, because whenever I think of scatter, I think it has like scatter and absorption together, and transmission totally separate. So adding that indirect transmission is a result of scatter is I can already see it. I get it right now.
Okay, how about we flip it and say scatter is a result of indirect transmission.
Okay, I think I can get behind that.
And photons that strike the IR are called transmitted photons. Alright, we already know what the IR does. Collects information from both direct and indirect transmission to form our image. Direct is useful. Indirect is scattered, so not that useful. And we know the types of different IRs that we have. Alright, so there's different types of photons. Primary photons, just like it sounds, it's photons from the primary radiation. Exit photons are basically photons that exit the patient and reaches the IR. Okay? So where does primary photons exist? In between what and what?
Patient
Tube and
and
patient.
tube.
Exit photons,
Patient and I.
patient and IR, okay? And then photons that do not reach the IR are attenuated photons. So they've been
Or they-
absorbed or
or
they've
they
been
get
scattered
cut.
and flew off into the side. Alright, yes.
So, a lot of, so is coherent scattered considered exit photons? Cause a lot of times those are the ones that end up going to the IR rather than.
coherent, a lot of them be
They
absorbed.
get absorbed only.
Oh,
This
We'll,
thing.
we'll get into that in just a second.
okay.
Hold your horses.
Hold your horses, yes. Small angle scatter is another name for exit photons that have exited the patient, but they took a different direction than the primary photons. Okay? So primary photons, they just go straight through without interaction. But small angle scatter, they also exit the patient, but they probably slow down and change direction. Okay? And this is the photons that cause noise or radiographic fog, and they also blur the outline of structures. Small angle scatter is directly related to the amount of tissue irradiated. Therefore, it's important to collimate.
The more open you keep it,
You get
the
more
more
scatter.
scattered.
Alright, so we're gonna talk about some photon interactions. So this is interactions between X-rays and what?
Matter,
The
tissue.
patient matter, yes. So we have coherent, photoelectric, Compton, pair production, and photodisintegration. The two that we talk about in diagnostic X-ray is photoelectric and Compton, which is important in X-ray. So, coherent scattering, what are some other names for that, Johns?
Elastic.
Elastic,
Thompson.
classical,
Thompson.
Thomson, and unmodified. So coherent scattering, there is no loss of energy. And I'll explain what that means in a second. These typically occur at energies that are lower than 10 keV. So very low energy, which is why, what happens to them? Leads to absorption. Most of this,
What happens to them? They get absorbed.
they get absorbed because their energy is very low.
Yes.
Most of the time, inherent filtration will remove these photons.
So if they're not removed, they'll be absorbed.
Because their energies are very low, they cannot really keep going through the patient. Alright, so what exactly happens in coherent scattering, if you guys remember?
It happens in the afternoon.
Photons,
They get excited.
photons.
Yeah, they get excited and use the same energy.
Okay, so energy from the X-ray photon comes in and then interacts with outer shell electron, and then what happens?
It gets excited.
Excited.
Gets excited. Does it eject the electron?
No.
No, it does not.
But it has low
It
energy.
just gets excited.
It just gets excited because the photon has such low energy,
It gives them
it's lower than the binding energy of the electron, so it cannot eject the electrons. But it does interact with the electron, which causes the electron to get excited. Once the electron becomes excited, it gains a sort of a vibration, and then once it's back to being relaxed, what happens is that electron releases another photon of the same energy. That's why there's no loss of energy with this scattering. Does that make sense?
Yes.
Okay. Do I need to repeat myself?
Yeah, 'cause my recorder stopped.
So with coherent scattering, energy from our X-ray photon is coming in and interacts with what?
Outer shell.
Outer shell electron. And because our energy is so low, it's lower than the binding energy of the electron, so does it eject the electron or no? Does not. But what does it do?
excites.
Excites the electron, and then once the electron relaxes, what happens?
Another photon of the same.
It releases a photon of the same energy that it received in the first place. And that is why coherent scattering deals with no loss of energy.
Does they go in a different direction or the same direction?
The photon?
Mhm.
Yeah, probably goes in a different direction.
Is it? None is this coherent scattering, is like you started, these are the different type of scattering that you're talking to talk about.
Yeah.
What is coherent scattering comes in there? Type of scattering or type
Coherent
of?
scattering is absorb, remember?
So we're talking about.
Because it has really, really low energy. So the photon that the electron emits, once it relaxes, it still has the same low energy. So it's going to be absorbed.
And this happens in the patient, not in the
So,
No, not in the tube.
so it's an
Because this is
attenuated
happening after.
photon, or is it an
That's
active?
inside the patient, inside the patient.
So yes, although the photon has the same energy, it may have a different direction. Most often, it is going to be a 20-degree deflection from how it initially came in. And then, what can it lead to? Small amounts of radiographic fog. So low energy scatter. This doesn't significantly affect our X-rays. Yes.
So, if there's a question that asks, like, is this an attenuated photon or an exit photon?
It's not exiting.
It's
It's
not
attenuated.
exiting at all?
No, because the energy's so low that it's being absorbed.
So it's still, but it still causes fog on the image,
Mm-hmm.
even though it's being absorbed?
Wait, hold on.
No, it exits the atom in a different direction with the same amount of energy, but it usually doesn't exit the patient
It-
because it's
yeah.
absorbed in the patient. But if it does, it's a low, leads to a low amount
Energy.
of decrease of contrast in image.
So we can't.
So,
Yeah, if
And
it,
that's
If
what
it still does, it's a low.
Typically,
amount.
it doesn't exist because it has such low energies.
Yeah.
But I mean, we can't predict what it does.
scatter
It
is
may, it may
Because
exit
it's
the
always
patient.
filtered out
Uh-huh.
99.9%.
And if it does, it leads to a small amount of fog, but it's low energy scatter.
Yeah, I understand that, I'm just asking, should I consider an exit photon or attenuated photon? Because it does both. So, I'm just saying, I just didn't want like a
I
question
don't-
to
I'm
come
not
up and be
asking
like, I
questions
don't know
like
how
that.
to answer it, you know?
I'm not gonna ask you questions like that.
Okay.
But basically, exit photons are photons that exit the
Scatter
patient.
is attenuation.
It's attenuated because it's absorbed.
It is attenuated.
Okay.
It's attenuated.
Can it come towards us? If it exists, the patient.
It's, yeah, I doubt
It's
it.
either filtered out or.
Unless you're standing right next to it, John.
Whole movie.
Whatever it is, he's not gonna ask.
She might know, but you know who I am.
Y'all
Y'all know who I am.
Not the ball Stop. Alright, photoelectric absorption. What happens with this?
The photon comes in, hits the inner shell.
Photons come in, is it in the patient?
Interacts with the inner shell of the electron.
So photoelectric absorption, the X-ray interacts with what?
Inner shell.
Inner shell electron, and then the what?
It's kicked out.
Kicks out the electron.
It's kicked out, and why is it kicked out?
Because
Because it has enough energy to.
Because the
Knock it out.
energy is higher than the binding energy of the electron that it kicked out.
And then cascade comes in.
And then once that electron is kicked out, what happens?
Because
The outer shell electron jumps to it.
There's a vacancy, right, where the electron was kicked out.
Yep.
So the outer shell falls down and fills that spot, and what happens in that process?
some energy is released as carbon top photon.
Energy is released that we call characteristic photon
That's
or
correct.
characteristic X-ray.
That's correct.
what happens? I have a question.
Yes.
So then,
During the cascade effect, what happens to the outer shell electron? Like, what comes into the outer shell electron?
Outer shell electron, they may try to create bonds to share electrons. Because remember, they're trying to fill their outer shell with 8 electrons,
Mhm.
so they may do that, but not for sure what happens.
Mr. Funk said that one of the one that's floating around, they just come make.
Oh, they just grab a floating electron?
Yeah. That's what he said.
Okay.
Because they don't have a house, they're homeless, so then they go to the outer shell.
Yeah, he gave me a whole scenario.
he said they homeless.
So photoelectric absorption, this process repeats until there are no vacancies in the inner shell. Okay?
So the
So once it ejects the inner shell electron, one of the outer electrons jumps in to fill that vacancy, and then, what do you mean?
So you could create an X-ray within this.
So once the electron jumps in to fill the position, it releases energy that we call characteristic photons or characteristic X-ray.
It creates a characteristic,
That's it.
photon, but it's in a smaller energy level, so it's usually absorbed. It does
So-
create a
Mhm.
photon from that, going from the outer shell to the inner shell, it creates a set characteristic photon. But then it's just a low energy, so it's just gonna be eventually absorbed.
So this creates its own X-ray within this whatever it was absorbed into from because of the cascade effect.
Yes.
That
And
is-
usually the energy that's released is around 10 eV, which is low, and it tends to be absorbed by the body also. So the way I remember is photoelectric absorption has eyes, so inner shell. Whatever helps you out. So yes, the ejected electron is known as a photoelectron. Okay? And the energy of this photoelectron is the energy of the initial photon that came in minus the binding energy of the shell from which it was ejected. Okay? This electron can interact with other atoms either by excitation or ionization. The photoelectron that's created is usually absorbed because why? Low energy. And because it is absorbed, it results in increased patient dose, but does not really contribute to the radiographic image. Alright, so this is probably a new term. So this is not
Sounds like J.
ogre or auger. It's French. It's auger. Auger effect.
It sound like who?
Auger. Auger.
Ajay.
At least she didn't say all gay.
Oh my
And she
God,
points
that's
at you.
very funny.
She said, oh.
So
dang.
Auger effect is actually another effect of what happens in photoelectric interaction. So when the outer shell electron fills the vacancy in the inner shell, it releases energy, correct?
Yes.
The energy does not take the form of a characteristic photon. Instead, what happens is it travels to another electron within the atom and ejects it. So this is a different stuff that's going on.
In the body.
It's a new
So it can also do this. It can
Yeah, so not only can it do the
this.
this,
Okay.
but this effect can also happen.
Okay, I see it. I'm following.
So if
So-
it ejects that other,
So once the inner shell has been ejected, what happens? The outer shell does what?
it fills
I'm in the
it.
cascade.
Fills that vacancy, right?
Yes.
This action releases some energy,
Mhm.
which interacts with another electron and ejects that electron. So this
And-
is something different that can happen.
Is in the same atom, correct?
Yes.
Is that gonna cause is that gonna cause a cascade again?
Oh, that I don't know.
And it's not the inner shell electron.
To another electron.
It's not the
Yes.
inner shell electron.
So that energy, it interacts with another electron within the same atom. Is what this effect is saying.
Not of the outer shell electron. Inner shell electron.
So
only.
it's like the beginning process of the photoelectric, the beginning of that, but it just release the energy, interact with another electron within the same atom? You
Or
know,
this
like the
can
beginning,
happen.
it hits the inner shell.
Does this connect?
Hold on one second.
Travel to another electron.
And then it's still in the same
Thank you.
atom.
What?
Energy created
Are we
with-
talking about-
when filling
The photon that's created from jumping?
Y'all got me all kinds of confused. Okay, so,
We'll come back to this.
Put a
No,
pin
Our
in it.
next step.
hold on.
Or emit.
What travels to?
So once our inner shell electron is ejected,
Mm-hmm.
we know that the outer shell jumps in to fill that vacancy, correct?
Cascade effect. Uh-huh.
Which releases
Energy.
energy. Now what happens to that energy?
It kicks out some of the electron in the atom.
In act.
Interacts with another atom.
And another electron, sorry, not that.
Right.
People say it should be another atom.
Let me see, what do you
So
guys say?
in
Go ahead.
That right there can interact with another atom. Why would it be interacting with an electron?
What? I'm getting confused with two different things.
H students, yeah, trust me.
They're not the same thing.
You read the book, Martin?
This is saying that it doesn't go away, it's still in this
How long
atom.
is this class?
Yes, that's what it's saying.
So,
Yeah, so the
which
energy,
electron is it interacting with?
Any of
the
them.
energy that is released is,
the
the electron released.
it's
but-
within the atom.
Yes, it's within
Any
the atom.
electron in the atom.
Within
Energy
the
that is
same atom.
released, it acts as.
So the energy that's released
Mhm.
travels to another electron within the atom and ejects it.
Mhm.
That is the Auger effect.
Yes.
So they said that it can either create one of
So,
these
part of-
or the other one.
Correct.
Right,
Yeah,
the
so
part of
this
the
is
energy.
a different effect. Yeah,
Mhm.
it looks like.
And the electron that's ejected is known as the Auger electron.
That's right, it's
The,
exactly.
part of the
And
energy released.
what-
Explain the whole process again.
Yes. I will have to reread this because y'all confused me.
It turns into
This
a
is
new-
a radiation-less effect because why?
There's no X-ray
We're not creating
emission.
X-rays.
There's no photon.
Which is a radiation, or
Yeah.
the auger,
The Auger effect.
Auger.
Because all it's doing is ejecting another electron.
So that's like a second name for it? It's radiationless effect?
No,
No,
this
it's
is just
just a
known
name.
as a radiation-less effect. It's not another name for it.
So,
Okay. Because it's low.
okay, what's the difference between this and then regular?
so photoelectric.
So photoelectric absorption, once again,
Mm-mm.
it's an interaction between an X-ray photon and
In a shell.
inner shell electron.
Okay.
So the energy from the photon is absorbed by the electron, and then what happens to the electron?
It's kicked out.
It's kicked out from the atom, okay?
The remaining.
Now, once it's kicked out, it leaves a vacancy, correct?
Yes.
Okay. Okay, and so what should happen to this vacancy? Outer shell fills it in, okay? And once the outer shell fills that spot, what happens? It releases
energy.
energy that we call
Characteristics.
characteristic photon or characteristic X-ray. So this is radiation effect because we're creating X-ray.
And
Okay.
sometimes it doesn't create that, right? That's what I.
Sometimes this is not what happens.
Yeah.
We may have this.
Oh,
Outer shell electron fills the vacancy, but instead of creating that photon, what happens is travels to another electron within the atom and ejects it.
And then it's an
You have the.
That's
Auger.
called a Auger electron.
Oh, it turns into a different name, like a new person.
Yeah.
So it's not the same.
Yeah.
Basically, okay.
It changes its weight.
New electron, new
Okay.
Yeah.
Go back to the slide.
And why is this effect radiation-less again?
We're not creating
No.
X-rays.
We're not creating X-ray.
Thank
Yeah,
you.
we're not creating X-rays.
Now, did I lose anyone?
Yes, because I thought anytime you eject or anytime a electron is right, is that ionization? The removal of an electron.
In this case, it's not.
Well, I understand why not.
Cause science, I don't know.
Because
It's
So,
too-
I mean, it's-
in this
I mean, it's
process,
confusing,
So you're
but
saying
like,
it kicks it out and then it just goes to another electron and kicks that out?
yes, so in this process, outer shell
A butt kicker?
jumps in and fills the vacancy in the inner shell, okay?
Mhm.
And then energy is released in the form of X-rays.
X-rays, yeah.
But
Which is
in
called-
this effect, when the outer shell jumps in to fill the electron, we're not releasing energy as X-rays. What are we doing instead?
Creating a
Creating
object.
Creating the Auger effect, where it just kicks out another electron.
That's it. It just be like.
This
you know,
happens how
you know,
The probability of this is, I think, very low. From what I read.
So it's not always that one is
It's
filled out.
either gonna create a photo
Design.
electron or an object electron. Okay.
Auger effect.
100.
So with photoelectric absorption, either we get a characteristic photon or we get an Auger electron. That's it.
But
And that's all, folks.
It's,
Or there's some
it
other-
may happen simultaneously because interactions are happening. Many interactions are happening at the same time.
that it travels to another electron.
The
It does.
Are you
Take
saying
it
that
out and take
it
it
does
out.
with one and now it's going to another one?
Oh, she a gold digger.
wait, what? So once the outer shell fills the vacancy, it releases energy, but it's not in the form of a photon.
That's right.
Okay? The energy travels to another electron within the atom and ejects it. So energy can exist in different forms.
Yeah.
This one is not taking the form of a photon.
You gonna have to see her after class for
Can
this.
be converted into.
I mean, I don't understand, like, is this a whole different thing, or, I mean, you're saying that
So
photoelectric
this is
hap-
another
happening
effect of
and-
photoelectric interaction. This is another effect of photoelectric interaction. We either get a characteristic photon or we get Auger effect.
So either or, or it happens both at the same time. That is created, and what I understand, that happens and
See,
then
box
it's
three
also
point four,
happens.
page 46.
But then
Atta
you
girl.
left.
Page 46.
How many?
That's the way she said she was gonna ask.
Oh.
Box
Oh, okay.
3.4, page
Don't come to me
46.
for any questions then, Monty. Alright, question. The highest energy level of photons in the X-ray beam is referred to as, we already know this,
KVP. 8 kilohertz.
PK.